So why does time have an arrow? If microscopic physics is mostly time-symmetric, you could, in principle, unscramble eggs. In the 187s, Joseph Loschmidt asked exactly that, and the standard answer leans on typicality. Given a low-entropy macrostate, most microstates evolve toward macrostates occupying more of phase space. But that line hides a deeper mystery, the past hypothesis. The universe began in a very special, low-entropy configuration. With that one boundary condition, arrows emerge. Memories point backward, radiation spreads outward, cooled coffee doesn't spontaneously heat. Without it, you'd expect Boltzmann brains, freak observers from thermal noise, more often than galaxies. Our reality looks nothing like that. So the crucial question isn't why entropy increases, it's why it was so small to begin with. Here's the everyday braid. Your fridge cools by dumping heat into the room. Its local entropy decrease is funded by an increase outside. Your brain learns by burning glucose. Order in synapses gets paid for with waste heat. Engines, ecosystems, neurons, all export entropy to build structure. That's not cheating the second law. It's the second law for open systems. The law is global and statistical. Life thrives in the gradients. Now the complication. If micro-laws are reversible, why don't we see large-scale unscrambling? Because records. Once information leaks into many degrees of freedom, air molecules, photons off a chair, bits in memory, the alternatives that could interfere get buried. Decoherence enforces a practical arrow. Histories separate when information spreads irreversibly. Erasing those records has a cost, Landor's price tag of KTLN2 per bit. Information is physical. Forgetting heats the room. And yet, if entropy is statistical, where does the certainty and doom talk come from? It comes from forgetting the ledger is patch-bound. We live inside horizons, causal boundaries that cap what can be accessed and stabilized. The second law applies to what's in play for us, given our coarse graining within our light cones. When we inflate that into an absolute cosmic verdict, we overreach. Another human moment. In a data center, a technician reroutes airflow. The temperature map on one dashboard shows smooth blue. A second dashboard with higher resolution reveals hot filaments carrying waste from optimized workloads. Same room, two macrostates. Smoothness in one view, structured currents in another. Efficiency isn't uniformity. It's targeted order funded by managed disorder elsewhere. This reframes the past hypothesis as design input, not metaphysics. A low entropy beginning sets up gradients. Inflation can compress and smooth, writing a tiny instruction set that later physics amplifies. But even before we reach cosmology, notice the policy.